In this video, we're going to provide a basic overview of .NET. Now, why are we providing an overview of .NET in the C#/XNA Extreme class? Well, simple. If you recall in the last video, when talking about what C# was, we were kind of forced to mention .NET a couple of times. C# was the premier language for the .NET platform. So, without .NET, there was no reason to have C#. Now, do you guys need to be .NET experts in order to create applications? Yes and no. You need to be aware of what .NET offers in the base class libraries. And there are thousands of classes already created and ready to be used. You also need to have a general understanding of what happens when you compile your application and what's required to make that application run. Because in the end, you're going to be writing these cool games and you're going to be sending them to your friends, and your friends are going to be messaging you or calling you and saying, hey, your game doesn't work. So you're going to need to be aware of the .NET runtime and tell them where to go and get it. So because of this, we need to give a basic overview. Now, so many people all describe .NET differently. If you don't believe me, get on the internet and look for a basic explanation of .NET. Go to Microsoft's site. Have a good time. Even within Microsoft's site, between different versions of .NET, you may find information that may seem confusing or abstract. I promise you that. Or better yet, start comparing the information from Microsoft's website with books or other websites that have written articles on .NET. It can get confusing really fast. We're going to throw around some of the common buzzwords found with .NET in this video, and some of this is going to feel like it's going right over your head. Our goal is to keep this as simple as we possibly can. Just please bear with us. And if you don't get it, by the end of this course, come back and watch this video again. I bet you some of it's going to fall into place. But we're going to do the best we can to make it as clear as possible. So with that, let's get started. .NET. What is it? Well, .NET is the solution. The solution? Well, to understand the solution, you must first understand the problem. Well, what's the problem? All right, well, you ask, let's pull up my whiteboard. So let's go ahead and bring up a couple layers so that I can do a little bit of writing for you guys. We all know that there are a lot of different programming languages out there. Let's draw a couple of them. I'm going to go ahead and throw C# up here only because we're going to introduce .NET, but without .NET, there's really no reason for C#, if you will. So we've got C#, let's just throw VB up here. All the applications I'm throwing up here are going to be the .NET version of these programming languages. So let's throw up here C++, and let's do something crazy. Logan, how about we throw up something from Borland? We get outside of the scope of Microsoft altogether. That makes the problem a little bit more sophisticated. So let's throw up Delphi. Object Pascal, for those of you that are going, what's Delphi? And no, it's not Delphi, for those of you in the UK. If you don't believe me, call Borland here in the United States. Okay, so we have all of these different languages. Now, what I'd like to do is draw some targets. We've got Windows 98. Oh, shudder. We've got Vista. It's new and improved, so they say. We've got web apps. All right. Nothing like web forms and some web services. Now, obviously, some of these things are simply outside of the scope of what this class is all about. But I'm going to throw them up there as part of the problem, because indeed, it is part of the problem. Logan, you were going to say?
And not only that, they add a great deal of complexity to the problem. If you think about the differences between an application that might run on Windows versus a web app, which is viewed entirely through your web browser and transmitted via HTTP to your web browser. So it's two incredibly different worlds that we're talking here.
Absolutely. So here's what I'd like to do. I would like all of these languages to be able to produce source code. Well, no, let me not even say it that way. I'd like all of these languages to be able to produce something that they can all work back and forth between one another and share. And then I'd like the output of that to be able to function on any of these target OSs or a web app or a web service. So let me do this. We're going to draw this giant area in here. And .NET is going to have to fit into this. Now, in the old days, let's pick on C++. Let's say in C++ I was going to write, I'm going to add a new layer real quick. I was going to write an application. So I come in here and I generate my source code, right? And then with my source code, well, I need to know what I'm targeting. Let's pretend that I am targeting Vista, okay? So now I'm going to rely upon libraries that I know exist within Vista that can produce specific results that I'm looking for. I'm simplifying this as much as possible, so please bear with me. So I make my own function calls to these libraries, and I get work performed by these libraries, and I get results back, etc. So I write my source code, and then what do? I compile this. And let's say I compile this to an executable, an exe. And now with my executable, I can take it and I can run it on Vista, and it runs just fine. Now I need this same application to run over here in Windows 98. Let's say the client that I developed the software for had it running on Vista and then wanted it done on 98. Or better yet, let's say I designed it originally for 98 and they just went out and upgraded to Vista. Now, let's just kind of reverse the example just a little bit. It does work either way. Let's say that I'm doing something in 98 for whatever reason has been changed such that in Vista, if I was to try to run the application, it would crash or just not run at all. Now I've got a problem. Now I've got to come all the way back in here and rework my code a little bit, don't I?
Right, because in this process you've described so far, you've controlled every single step. It was more or less your responsibility to make that final piece of code. And if that final piece of code doesn't work on any of the systems, the only option you have to change that is your source code.
That's right. Now let's make it more interesting. Let's say that I am up here, so here's Jason, and here's Logan. And we need to work on a really large project together. Logan is creating an engine that's going to work with sound. And I'm working on, let's just say, the graphics engine. Now, he wants to use Delphi. That's his native language. That's his baby. So he's working in Delphi, and I'm working in my language in C++. So here he is. He's generating some code. So he's all happy and all. Now, we need for our pieces of code to talk together. This is completely doable, but it's not very simple to just jump right in and use it.
No, we have to sit down together and first work out what pieces of code we're going to share, how those pieces of code work, and what to expect when you're using them. We can't be separated into two different buildings or into two different parts of the world to work on this without communicating. It's up to us entirely to make these pieces of code work together. There's nothing that will tie them together. If developer 3 was to take our two pieces of code without documentation and attempt to use them together, it'd be a nightmare. He'd have to understand and possibly rewrite both of them.
Okay, so you're saying we would have to sit down and define a standard on how our pieces of code are going to work together.
Precisely.
Wow, this problem is getting bigger by the second. Now, let's throw one more thing in there, and that is ease of application development. Okay, we do have the Microsoft Foundation classes from way back in the day, right. And there's tons of classes that were already developed, and we could use those in creating Windows applications. That's cool, but we start to get a little bit more interesting if we start throwing other targets in here that we want to go towards. Like what happens if, let's say I want to throw a PDA in here that is running the .NET Compact framework. And I want to be able to write an application for that. And I want to be able to do it from, say, Delphi or C++. Okay, now things are going to get a little bit more confusing as, well, all right, what can I use? What can I do? How can I write this? Now, as you can see, we're definitely presenting a bit of a challenge here. Everything's doable that I'm describing.
Right, at the very least, looking at the PDA means you're going to have to go back, learn the standards, learn the API for that PDA, see if any of your existing code is even applicable, and rewrite the parts that are not.
And notice how Logan just said the API for the PDA. But if we don't have Microsoft Foundation classes available on the PDA. So now if we want to write an application that's going to run on Windows 98, and run on our PDA and run on Vista, wow, the planning that's involved, the complexity
Not
of
only
the project
planning,
itself.
The deployment itself.
Ooh.
We're going to have someone in charge of maintaining different final versions of the program, different versions that run on Windows 98 versus the ones that run on the PDA. The PDA isn't even going to attempt to run a program, a standard executable for 98.
Precisely. So that's our problem. So for the solution, what Microsoft did is they came up with some objectives. And I'm just going to read you a few of them. Some of these have been simplified a little bit. So some of the objectives of the .NET framework are to support standard networking protocols and specifications. Beautiful. So now we make networking communications, or we're working with communications simplified with TCP/IP as well as other protocols. We need to support different programming languages. Well, that fixes the problem right there that we're staring at. C#, VB, or we could just say VB.NET, C++, Delphi. You know, there are over 20 languages that are .NET compliant right now, and more that are being added. That's amazing. So that objective, to support different programming languages. All right. To support programming libraries developed in different languages. Haha, here we go. Logan's designing a sound engine for me that I can now use, and I want to be able to do it with ease. So again, to support programming libraries developed in different languages. To support different platforms. Are we not doing that right here? Windows 98, Vista, web apps, services, PDA. What if I was to sneak some slick ones in on you, like Linux or Mac? Yes, we know about the Mono project. Yes, we do. So all these different targets. Wow, very cool. So I need to be able to support different platforms. We need to provide a code execution environment that minimizes software development and versioning conflicts. A code execution environment. That really lies at the heart of this entire thing. What am I talking about? Well, if I was to come in here real quick and just hide all of this, throw another layer up real fast. What if I was to have a common language runtime that's going to handle, and this is very abstract, folks, for those of you that may have a better or, let's just say, knowledgeable understanding of .NET. So a common language runtime. So let's say I had one that handled Windows 98, and it was aware of Vista, and it was aware of handling web apps type stuff when we start talking about ASP.NET, etc. And again, web services. What if I had a different common language runtime that was able to talk out here to Linux? How would all this work? Well, here's the deal. Basically, what's going to happen is we're still going to have to compile from all of our different languages. So what if we compiled, and the output of what we compiled was a program or an assembly that could then be read by the CLR, and the common language runtime would actually compile it to the target's native language on the fly.
So it's basically like we write in this CLR special code.
Right.
That we write in some kind of code that a CLR understands. Any CLR, the one for 98 or the one for Linux.
So this right here actually becomes a language for this guy. So how about we call this something like intermediate language, or IL. You will also see it referred to from time to time as MSIL, Microsoft Intermediate Language. That is an L, I promise. So that is what this is. So our common language runtime needs to be able to take this intermediate language. It's like bytecode, right? It's been very much simplified. We've got all the text out of there, and we just got a bunch of codes in our data in there. And it needs to take that and compile it for our target. And it's going to compile it on the fly. And that's called JITting, just-in-time compiling. And the first thing that may come to a beginner's mind is, oh man, that's going to get slow. Because before we compiled it straight to a native executable, native to the operating system we're planning on running this on. But now you're wanting to compile it on the fly, and I just don't see how that could possibly be faster. Well, there's lots of arguments going on the internet about this. But Microsoft argues that when it starts off, basically, first of all, we're able to take our common language runtime and we're able to optimize it for the specific target we're writing to, not only the OS, but the hardware as well. So let's say the difference between, a Pentium 3 and a Pentium 4, you get the idea. As our Pentiums have progressed during the ages, or the AMD has progressed during the ages, things get optimized every time around. So let's take advantage of these optimizations. And in the Common Language Runtime, we can optimize for that. Before, when we were compiling native code, it was just native x86.
Right, there was, you might remember applications that would actually tout the fact that they supported MMX or SSE2 or any other form of specific processor feature. What this means is that instead of the company you're buying the product from having to have that optimization already in place, instead just any general code, any code that anyone makes is now optimized for your processor as soon as it runs.
Right. So now imagine having a common language runtime that is optimized for whatever hardware you're using. So now you write your program. You're not even thinking about hardware. You don't have to care about that anymore. You know you're going to get the best performance you can because you're developing for a competent common language runtime. So now the common language runtime takes your intermediate language code and it compiles it on the fly. What does that mean? Well, you guys have seen in the Hyperion project, we'll use that as an example, that we had a bunch of classes, and in those classes we had a bunch of different methods. There were methods that we may have never called upon. Like, let's say we implemented the jump method.
Or even better, the get coordinates. We implemented that.
Okay, that one did get implemented.
We implemented it, but we actually took its display back out. We stopped using it in the final version. We only used it for testing purposes.
Just so that it would tell us what room coordinate we were in. Now, at runtime, when that method was called upon to actually execute, that's when the Common Language Runtime JITted it. That's when it compiled it. But now when it compiled it, it basically stored it in cached. So that if we called that method again, it's already been compiled. So what happens when you keep doing this with all of your methods, your application gets faster and faster and faster because more and more methods get compiled. Now Microsoft argues that one of the things in performance here that's nice is, well, if you have a massive project and you go to compile the entire thing every time, you're dealing with a lot of waited time. You're just waiting around for the compiling to take place. But by doing just-in-time compiling, you don't even worry about that. You just write test, because those methods that get called upon, they're the ones that are getting compiled on the fly as they're needed. And then they get cached. Anything you want to add to that, Logan?
Right, and in the sense of using a big application, what that would mean is you load the application and then things that would get JITted or compiled would be maybe whatever is necessary to display the main menu.
Right.
Then you enact an operation. You say open, and the code necessary for opening a file is then JITted. So that way it gets compiled piece by piece as you use it.
Which is going to be very fast. And again, using a common language runtime, that's going to be targeting optimizations for your hardware. And OS.
So after it gets JITted, then at that time it runs, and then every subsequent time it runs, you have code that's directly optimized. It's almost like, you remember the stickers that touted MMX optimization?
Oh, I do.
It's like taking any program and saying optimize for and giving a picture of your computer to stamp on it.
Precisely. And another thing, back to Microsoft's argument, in compiling the entire thing, and now you're waiting around, you've just made a couple small changes. You need to recompile the project. But you're only going to test one little thing. So now you've got all this wasted downtime while you're compiling. Again, we're discussing large projects that take maybe 10 minutes to compile. And then you're going to turn around and test this one little thing only to find out you introduced a bug. Well, that's a lot of fun. Where if you were handling the just-in-time compiling, you can make a change, run it. It's that fast. So very handy. And again, in JITting, it gets cached. Once the method has been JITted, it's cached and then can execute the next time around. That method is called quicker. So what if we did something like this? So again, now this goes back to, now recall, right now this whole discussion came from us walking through some of the objectives of the .NET framework. And this one was with the mention of to provide a code execution environment that minimizes software deployment and versioning conflicts. Okay, so here we are talking about a code execution environment. Another thing they have as an objective was to provide a code execution environment that eliminates the performance problems of scripted or interpreted environments. That's right, scripted or interpreted environments. There are, well, plenty of scripting languages out there that are interpreted. They are going to be executed line by line by some other service that is going to interpret what it is you're saying in that script line and then perform whatever action you wanted it to perform. Again, line by line. Interpreted languages equals slow, right, Logan?
Right, because the interpreted language itself almost has to act as a virtual host, which makes these magical or otherwise non-CPU runnable things work. All of the functions defined in an interpreted language exist only because that interpreter is running.
That's right.
So then you have one instruction in the interpreter could easily be 10 or 20 or more instructions on the actual native machine, like to add some complicated adding function. Could in fact be more complicated than the computer's version of add two numbers.
Exactly. Wow. And this is only some of the objectives. The objective list goes on forever. I mean, basically Microsoft said, our objectives for the .NET framework is to redefine the world. And I just didn't have 500 hours to discuss all this with you guys. So here we are at some of our key points that we need to cover. Okay, obviously the big thing is the ability to write code in C#, because that's what we're going to be doing in this class. Get that code compiled into an intermediate language, and then let the common language runtime take it and go from there with our target. In the end, we're going to be taking our code over to the Xbox 360. Guess what? On the Xbox 360, our methods and our games are going to be JITted on the fly. And you'll be surprised, it's fast. It is very fast and very impressive. So, with some of these objectives, we are now able to finally tell you, so if I was to come over here, this will be fun, Logan, and do this, this, and this, and this. The basic overview of .NET. What is .NET? Well, we told you .NET is the solution, and we also told you that here was the problem, and we demonstrated it to you. Let me read to you the definition of .NET from MSDN. It's an integral component of Windows that includes a virtual execution system called the Common Language Runtime. You'll generally see it referred to as CLR. So it's a execution system called the Common Language Runtime and a unified set of class libraries. The Common Language Runtime is Microsoft's commercial implementation of the Common Language Infrastructure, CLI. Uh-oh, here we go. We're now throwing out some really crazy buzzwords. Common Language Infrastructure. It's an international standard that is the basis for creating execution and development environments in which languages and libraries work together seamlessly. Now, if you would like some light reading, remember I just said this is an international standard, the Common Language Infrastructure. Well, I just invite you to head on over to Google and do a quick search for it, and you can download it and read it. Here it is, the standard ECMA 335, the Common Language, or CLI, the Common Language Infrastructure. All 556 pages of this bad boy. There is a lot of information here, and a lot of this may seem very, very confusing. Have a good time reading it. It's a great read, actually. Well, okay, I haven't read all of it, but I've read quite a bit of stuff here and there. All right, so let's go ahead and jump back over to my whiteboard. So you've seen the standard does indeed exist. What does this give us, having a standard? Well, Microsoft is really setting ourselves up for something really neat. More and more people can come in and generate compilers that will support the .NET standard, if you will, and more common language runtimes can be created supporting other target operating systems, hardware, etc. Okay, so this thing, it's big. I mean, it really is big, and it continues to grow. Now, let's go ahead and let's see. What do we want to draw now? How about let's just kind of draw out what this thing looks like, or better yet, if you guys don't mind, I'm just kind of jumping around right now because, well, I'm just having a little bit of fun with this whole thing. Let's take that off. This, again, I consider this kind of bonus material way above and beyond what is needed for this class. But I'd like to share it with you guys because I think it's good stuff to know. So how does it all begin? Well, the whole thing is we've got to have a spec, if you will. So let's start off with the CLI. And if I can do this without it jumping all over the place. So this is going to be our common language infrastructure. Now, the CLI, the Common Language Infrastructure, it's going to provide the specification for executable code and the execution environment. Remember when we were talking about that common language runtime? Basically, this is our spec for the whole thing, this whole concept of being able to have assemblies that can use one another, that were written in other or various different programming languages that support this, and then can be compiled on the fly by some sort of common language runtime. Okay? So this is the spec. Now the spec breaks down into 4 areas. So let's take a look at these 4 areas. The first one, as I go marking up all over the place, the first one is going to be the common data type. So we'll call this the CTS. Common, what am I saying? Common data.
Common type system.
Yeah, common type system. I'm you know, yeah, stuff. All right, CTS. This is one of the first of the 4 parts, the common type system. Here's the problem. I have all of these different languages, right? I've got VB.NET, I've got C#, I've got C++, and so on, Delphi.NET. You know, in each one, to have programming languages that are able to work together, when it comes to data types, we have to agree on something. An integer in C# better be the same as an integer in VB.NET or an integer over in Delphi.NET. So we've got to commonize this, if you will. So basically, the CTS, in its most simplistic definition, is going to be to define a base of data types that are available in the intermediate language. So if I was to, in C#, define an integer, I do that by typing int, space, and then I give it my name. In VB, I type in integer. Okay, so actually the whole line's going to be different, as I'm going to do like a dim I as integer. Now, what are we looking at? Well, in our CLR, the common type system is going to define this as an int32. So through data type aliasing, we're able to say, all right, in C#, int means it's an int32. Over here in VB, integer, it is an int32. So in the end, both in C# and in VB, we are storing the exact same kind of data. So now here we are with the ability to interchange that data back and forth because of the CTS providing this standardization for us.
Right. That means that in the at the CTS level, we've defined that one of the things that we want to be able to store is a 32-bit integer. So we have an int32 type. But now we've got 2 languages, C# and Visual Basic. C# is keeping with its C heritage, in that you would define an integer by using the int keyword. Visual Basic.NET is keeping with its VB heritage, in that it's using the keyword integer.
That's right.
Now, because we want these 2 languages to interact, we have them agree on the fact that an int or an integer are both the int32 type. So they are really, and behind the scenes, in the .NET sense, they are the same type.
Precisely. Now, when we get into all the data types that's defined, it actually gets quite sophisticated. And we're not, of course, that's way beyond the scope of this video unless we want to spend a whole lot of time. Actually, you can have an entire course on the common type system. But again, for some light reading, head back over and read the spec that I pulled up earlier and have a good time. What was it? The ECMA 335. That breaks down the common type system quite nicely. But the common type system is the first of 4 parts that make up the whole common language infrastructure. So now that we have our languages all agreeing on the types, next thing we need to do is, well, we're going to have let's go down here, a common language specification. So common, yes, I'm going to write all this out. Language. I'm just going to put spec. So our common language specification. And basically this specifies a subset of the common type system and a set of usage conventions. Logan?
Well, what happens here is that the different programming languages that may all support .NET can be very different in how they actually work.
Right.
For example, in some languages may be case insensitive, and others may be case sensitive, such that a casing difference could imply an entirely different type or keyword or method or what have you.
Well, just to break that down quickly, VB is case insensitive. Okay, so you can use uppercase, lowercase. If it's the same word, it's the same thing. Over in C#, we know that's case sensitive. So if I was to create a type with the name of, help throw something out, test, with a lower t, and then another type with test with an upper t, over in VB, if we wanted to use any of the code that was created in C#, we've got a problem. Because those two tests in VB, casing doesn't matter, so it's the same thing.
Right, and if you attempted to actually type that out, you would probably run into something like the whatever you were trying to type is already defined, because it was whatever came first.
Precisely. So this is where our common language specifications come in. It's the bare minimum things that the languages need to be able to agree on to use what they produce back and forth between one another. Anything you want to add to that, Logan?
Right, and then that would include things like having to be case insensitive so that languages like VB could interact with other languages.
As a matter of fact, I'd like to demonstrate this to you guys here in just a few minutes. I'd like to get C# up and Visual Basic .NET up and create something in C# and show you how easy it is to use over in the VB.NET language, and also show you where if we create something that is not CLS compliant, that in C#, it's still going to work because we're within our base language right there. But if we try to use that assembly over inside of VB.NET, since what we're doing is not CLS or Common Language Specification compliant, it's not going to work. It's actually going to give us a problem, which is really cool stuff to actually see this in motion. The next thing I'm going to mention, which I'm just going to throw this out there real quickly, is going to be our metadata. All right, the metadata, this is going to be embedded in our assembly. So we saw how we can take a program, a source code that we write, run it through our .NET compiler for that specific language, and produce an assembly. Inside that assembly, we have metadata along with our intermediate language code. Okay? So basically, the Common Language Infrastructure is going to use the metadata to describe and reference the types defined in that program, in your intermediate language code. And this becomes really important because now we don't necessarily have to have documentation from somebody when we get one of their libraries to use.
Right, that's embedded directly in the assembly that you make along with the code that your compiler generates.
Precisely.
So that way the information is just available. That way, if you want to use an assembly in a different language, you don't have to worry about finding any headers, any support files, even negating the need for documentation in many cases, because you can just look at the metadata and see what's available.
Exactly. Now, the final piece of the CLI puzzle is going to be our virtual execution system. Which you're going to see often. It's our CLR. Yes, I'm making this nice and big. Why am I doing that? If you recall earlier, what did I say? Our Common Language Runtime is kind of the heart of this whole thing. Okay, this is our engine. This is what is actually processing that intermediate language code that was compiled from your source code and turning this into native language for the OS or the target system that we are running on. So the virtual execution system is responsible for loading and running programs written for the target.
Exactly. It's where you have the CLI that defines everything, and then you have the CTS and the CLS, the common type system and the common language specification, and these things let you make programs, and then let the programs interact, or let the program code interact with each other. Then you have to take all of that and feed that down onto the CLR for it to actually execute, because up until that point you've just been designing things, you haven't run anything yet. Now
we're going to beat this CLR thing up several times. We've actually got a couple of videos that's going to be addressing it. So if you're not getting it right now, don't worry. since this is the core of it, we're going to hit this one over and over and over just so you guys have a really solid understanding of what's happening there. So now that we've got the common language infrastructure in place, we've got this huge specification where now you can develop languages that are going to have a compiler that's going to make sure that everything that you do within is compliant with other languages that are all targeted for .NET. Now there are, for those of you that happen to be .NET savvy already, of course there are ways of, well, breaking some of these compliances if you want to, and we start getting into unmanaged code and stuff like that. Again, outside of the scope of what we're talking about right now. Is there anything you want to add about that, Logan?
No, other than that, the breaking that compliance can be either intentional or unintentional if you're just careless or get too comfortable with a specific language.
Exactly. Okay, so let's see. Let's throw in, instead of bringing it to a close right there, let's add some more stuff in here. How about, let's do this. This will be kind of cool. So here I am, and this is going to be recreated by Logan in just a second. So here is some source code in C#. So in a minute, Logan, I'm going to have you write me some source code. And here is some source code that was written in VB.NET. And again, Logan, in a minute, I'm going to have you write some source code in VB.NET too. Now, for this big picture to all come together, there needs to be a C# compiler. I'm going to just put comp. That is a compiler, people, not a computer. And this right here is the VB.NET specific compiler. So there's our compilers. Now, what do compilers produce? Compilers are going to produce assemblies. So different assemblies. ASSMY. Yeah, that'll work. ASSMY. All right, so assemblies. Now, what happens next? Now we start getting into the foundation of .NET. Next, this has to be, at execution time, run through our common language runtime. So here's our CLR. If you recall earlier, I mentioned that we have classes that already exist. We have a framework class library with just thousands of classes out there. So let me go ahead and draw this in there as well. Because in essence, these are the two physical parts of .NET that you can actually see and touch. So this is our framework. Class. Library. I'll just say lib. All right. Now, the CLR, of course, is going to be using this right here. And of course, when coding all the way back up here, we can make use of the classes that are available inside the framework class library. Okay? So now what I'd like to do is we feed, actually we just managed to, hang on, let me bring that back, there we go. We feed our assemblies into our common language runtime. And on the fly, the common language runtime is compiling, JIT, remember just-in-time compiling, so JITting out for our target. I'm just going to put OS down here, make this as simple as possible. So check this out. Now I can actually come in here and do something like this. I'm going to box this area in the best I can with my fantastic writing. Oh, look at that. And we're going to say that this is just .NET. Say a .NET runtime, okay? Now, of course, we've already seen that the big picture, all of this is swirling around inside the .NET language or specifications, etc., etc. As a matter of fact, we can draw a little bit more of that right now. Just the fact that we have the compiler producing IL code. So I'm drawing one of these cute little bubbles, right? And let's take this on around. And on up. CTS.
That, of course, defines what the assemblies can contain and therefore what the compilers are going to have to generate.
That's right, because remember, the assembly, when we deal with our data types and all, we've got to be dealing with supported recognized data types. It's got to be just a unified set of data types. Again, when C# compiles to our IL, it needs to be an integer that's recognized by our common language runtime. So again, agreed upon by the CTS. Now check this out. We can throw another piece of this puzzle in here. These assemblies, what if we want them to use one another? That means this area, we'll do another bubble. Or cloud. A cloudy bubble. Guess what this is? This is our CLS, our common language specification. If we want to make sure these two assemblies can work together, we need to be CLS compliant. And again, I can show you in a second where we can break this, where we're not following any CLS rules. It's not going to cause a problem. Our assembly that we write in C# will function just fine. But over inside of VB, we can't use it because we're not following the CLS rules. Okay? So here's the big picture. Wouldn't you say, Logan?
Right. What you just drawn, of course, the common language specification means that any interaction that takes place between assemblies is going to have to be CLS compliant.
Right.
And, of course, anything that happens at all with assemblies in relation to the CLR has to be common type system compliant, which means that the compilers have to take whatever we type and make it into common type system code, IL code, and then that can be fed off to the CLR, and that's what makes it so that any CLR can run any assemblies because those assemblies abide by the rules and types that are inside of the common type system.
And for those of you that have heard the term managed code, well, that's what the CLR is doing for us. It's managing our code. It's helping to keep things nice and safe. It's taking care of garbage collection. There's a lot of stuff that's going on inside this virtual execution system. We're just not getting that deep under the hood.
You could almost say it's an execution and management system.
Yeah, no kidding. So let's see. Anything else I want to add other than you could just put one final bubble, if we really wanted to, around all of this and say the common language infrastructure. And we could just put one more line all the way down to the assembly and say inside the assembly we have IL and we have metadata. All right, yes, .NET, ladies and gentlemen, in its most simplistic form.
And this has almost gone back to that initial drawing. If you look at the CLI, the Common Language Infrastructure, that was that solution we were talking about. If you look outside of that, we have different languages. And if you look at the result, we have code from either of those languages running on an OS.
Oh, you're so slick. We actually did that, didn't we? So if we were to turn this off and turn this back on, we have accomplished what we needed to. As a matter of fact, let me just go ahead and bring this down. We have filled that in. So we have gone from languages to different targets. Okay? Beautiful stuff. So Logan, I think to wrap this up by having a little bit of fun, let's jump over first into C#.
Okay. So
and let's do a very simple console app that is going to contain a method that allows us to add two numbers and return a result.
Okay. And because I'm going to want to get to the output, I'm going to name this project so it makes it easier to save and find it. So I'll just call this something simple, like maybe CLS test. So Common Language Specification Test. And here we go. Something that should be rather familiar. We've got...
Now, I just wanted to throw out this real fast, that this is something that you guys do not need to follow along with because you may not have VB.NET installed. I mean, of course, you can go to Microsoft's site and download the Express Edition for free. But if you'd like, just watch here. Okay, Logan.
All right. Now, inside of this, let's see. Even outside of static main, let's define our own method.
Okay.
Let's make a method. What do you want to do? Something that adds numbers?
Yeah, just adds two numbers and returns a result. So that over in VB, we can actually make use of this.
Okay. And since that is our goal, we're going to try to demonstrate some interactivity, which means that we want to get access to things we write here. I'm going to begin by making our class public. So right off the bat, we're saying, oh, okay, we're going to possibly use this from outside of
So we're going to expose
this
the class.
application. Exactly. So inside of our public class program, let's make our method for adding numbers. Let's make this method public, and let's make it static so that we don't have to first instantiate any instances. Let's have this method return an integer, and we'll call the method add numbers. Now, add numbers needs, of course, some numbers to take in to add. So let's say that it takes in two integers. We'll call them num_a, and num_b. And then I'll simply block in our method. Now we need to return our results, so we'll return, and we want to return the sum of both numbers. So we'll return num_a plus num_b.
All right, very cool.
And if I were to build just to check for errors, it looks like we're good. Everything builds just fine.
Okay.
And we could, of course, run, and we see the program start and run, but I never use any of the method, nor do I tell it to stop.
Right.
So, of course, the program just runs and exits. But we've defined this method, and if I, let me turn on our show all files for a second, so I could jump into bin, debug, and there we have the actual executable or assembly that we've generated.
Assembly will come in two flavors, .exe, .dll. Okay.
And this is of the executable variety because it is in fact a program that can be run.
Okay. So now that we have that, I want to go over to VB.
All right, let's load up Visual Basic 2005.
Dun dun dun.
And let's start a new project. We'll do a console app as well from within Visual Basic. So here we go. We have our main inside of
It looks a little cryptic. I haven't seen VB in forever.
But, all right, let's take a look at what we would need to do to use that assembly that we created over in C# and use something from within inside of Visual Basic. Now, the first thing I'm going to have to do is add a reference to that assembly. So I need to show all files inside of Visual Basic so that I can access references, and then I can right-click and add a reference, or you could probably go up to Project and add it there as well. But I want to add a reference from an existing project, or well, not just project, but in an existing file. So I'm going to go to Browse, which has us resting at our projects folder, which is fine, because we made our CLS test, which I haven't saved yet. So give me one moment while I switch back to Visual or C#. Save, and CLS test is fine. So now if I look, I have my CLS test project, which I can jump into, and if you remember, we had our bin, then our debug that I was showing earlier, that has our clstest.exe file. So we'll hit OK to that, and now you see we get a CLS test added.
Okay.
So we can actually take a look at what this...
Look at the file type. Show them the file type down in the Properties window where it says File Type. It's down a little bit lower. Assembly. Just wanted to point that out. Okay.
So let's take a look inside of this and see what's available. So
but Logan, how can we possibly take a look inside of it? Oh, wait. Assemblies have metadata inside.
Right, which describe what they have inside them.
That's right.
So I'll right-click and I'll bring up our View and Object browser. And this will load in all of the objects we have, and one of those is, of course, our CLS test assembly. If we expand that, we have a namespace. There we have namespace CLS test. If we expand that namespace, we have program. If we expand that, or click on that, we see all of the things that we have available within program. Again, program being the public class that we had back in C#.
Right.
So there's program. Here's things that are available to us. There's our add numbers.
Wow.
Let's click on that. Public shared function add numbers. And now this is interesting. We have things that are familiar like num_a and num_b. Other things that seem relatively familiar like integers. Only we didn't write integer last time.
That's right.
Back in C# we wrote int. So now we're looking at this, but we're looking at it through the eyes of Visual Basic.
Right, data type aliasing.
So, all right, now that we've verified that we have this, let's actually use it in code in Visual Basic. So I'm going to jump back over to the code. This, of course, also being a console application means I should have access to things like console.
And this should be very, look at that, guys.
Right line.
Look familiar?
So we've got our familiar console right line. Now what do we want to write?
And we're using stuff from the base class library right here. Console.WriteLine, that's an example. Remember, thousands of classes out there. Do you want to have to go through creating the class to handle writing something out to the console? I think not. That's redesigning the wheel. It's already there. Microsoft provides you with thousands of these classes for so many different things. Just a reminder, all part of .NET. Okay, continue.
All right. So now we want to reach into that functionality that we had that we added as a reference at CLS test. So we need to refer to this by namespace because, of course, I'm not using any of the namespaces yet, so we need to use the fully qualified name. That means we should be able to do something like CLS test dot, there's our program class from within CLS test.
Nice.
Dot, add numbers.
Very nice.
So do an open parenthesis, And then we're even given a tooltip as to what we need to do. We need to have our num A and our num B, and they both need to be integers. So we could do something like 5 and 7.
Okay.
And now...
Complex math. Hey, you wanted to put a terminator in there, didn't you?
All right, now, of course, if we were to run this, it should run, and then flicker. Let's see. Oh, I haven't finished the closing parenthesis.
You got to close off the last one.
So close off the parenthesis, run. It runs, but then disappears, so we can do the same thing. We should be able to have our standard read line. So let me grab console.read line. Now if we run, ooh,
12.
A result.
So, wow, we actually wrote a very simple engine over in C#, compiled that out to an assembly, came over into another language, made reference to that assembly, and used public methods available inside. And this is a very, very simplistic version of interconnecting two applications, if you will, or two programming languages. I mean, you can get a lot more complex if we wanted to, and this involves a heavier understanding of object-oriented programming. But what if we wanted to take a public class that's available in another language, in an assembly that was created by another language, and inherit from that class in our language, and then keep going by adding new functionality?
So we can actually build onto things that were first designed in other languages.
Wow, that's all I've got to say. Very, very powerful stuff. Well, that looks really good, Logan, but I think we could probably use this moment to give them a demonstration of breaking our CLS, our Common Language Specification.
Okay. Let's do something in C# that wouldn't be allowed inside of Visual Basic.
Here's a quick example. Watch this. We've got console, write line, then we've got CLS test. VB is not a case-sensitive language. So if we wanted to make some changes to case in there and then try running this again, if you want to do that real quick, Logan.
So if we take one of our consoles to lowercase console,
it still runs.
Well, actually, the language. Well,
let's
change the casing.
Change something else.
I've got a feeling that it's probably going to change.
Can it jump on all of them for you?
Yeah.
Oh, isn't that sweet?
Any ones that it can find. As a matter of fact, even if I define variables, it's probably going to do the same thing.
That's good enough. This example is going to work, though. Let's go ahead and jump back over to C# and let's create two things that share the same name, but the casing is different.
Okay. Like you had mentioned earlier, you were talking about a theoretical scenario where you had two methods, test with an uppercase
That's
T
right.
and test with a lowercase t.
Okay.
Let's actually write that out in C# and just see how C# handles it. Let's have a public static void, just so we can test something. We'll call the first one test with lowercase t. And, of course, it won't take in any arguments or parameters. We can block that in, and then we can copy the entire thing, paste it in below, and simply change the casing so we have another version with an uppercase T. And can we build? Certainly.
No problems. Okay, so now let's go back over into VB.
And actually, let me run this just to make absolutely sure that assembly got rewritten.
Okay.
So if we jump back over into VB now, let's go back into the object browser and take a look at program. We can see we have our add numbers, but where's test?
And yes, it would just update, by the way, folks.
So let's go back over here. It's like, oh, we can't see it in the object browser, but let's attempt to use it. Let's attempt to actually call it. So let me jump down right before our read line. Let me try to access, let's see, CLS test dot, yep, we still have program dot. It's not giving us test, but I'm going to type it in. Let's try the uppercase one. And we'll run it like so. What would happen if we try to compile it?
Oh, right there, it's already given you the answer. Look at that, test. It's ambiguous because multiple kinds of members with this name exists in class CLS_test.program. There we go.
Right there, it's acknowledged the existence
so it
of
knows
a test
it's there.
method.
It just knows there's two of them, and since this isn't a case-sensitive language, VB.NET, well, now which one? We don't know which one to use. They're the same thing, but they're not the same thing. So this is no longer CLS compliant right here. We just broke that. Now, of course, over inside of C#, as Logan demonstrated, there's no problem whatsoever. I mean, we can continue writing code in both of those. As a matter of fact, you guys have already seen it with us using the same name for fields or variables and then turning around using that name just with different casing for properties associated with that field. A little different here.
One thing that's interesting here is that if I were to comment out where I was attempting to use test and run now, it still works. Even though we have some non-CLS compliant code in the form of our test methods, add numbers itself is still CLS compliant. And that's one of the really neat things, is that CLS compliance almost works on a, I won't call it item by item basis, a method by method basis.
Meaning that if you break it, if you will, all you're breaking is the ability for your assembly to be utilized by another assembly because they're not compliant no more.
Right, and even then it doesn't break the entire assembly.
That's right.
It breaks the one method inside of that assembly.
Precisely. Again, this right here could warrant a much deeper discussion, and I am doing everything I can to keep this as simple as possible. I think this works pretty good. You, Logan?
I mean, it certainly does. It shows that, one, you can very easily use code between two .NET languages, C# and Visual Basic. It also shows that we do have to maintain CLS compliance if we want to ensure that our code does in fact function across different languages.
Right. So I think that's pretty much going to wrap it up. Basically, .NET is the solution, and we showed you the problem. All of these different programming languages, we want these different programming languages to be able to target different OSs or devices, and we want to be able to do this, well, quickly. We want to make programming streamlined. We want it all to be object-oriented. We want to be able to share assemblies between these languages. We want to make this whole thing as transparent as possible to the programmer. .NET comes in and it provides all of this for you. And not only that, they're nice enough to provide this humongous class library that we can build upon so that we do not have to continue to reinvent the wheel. It's just great stuff. So with that, that is going to wrap up this video with just a very basic overview of what .NET is.